Hello and welcome back to Precalculus1, section 2.2, quadratic functions. So the entire chapter is devoted to polynomials. And the quadratic function is the second order polynomial because we have x squared. So prior to quadratic function, you learned everything you need to know, everything that exists on linear lines. Linear lines, y equal mx plus b, are also polynomials. They belong to the same family. And also constant function, like y equals to 3, they also belong to the same family. I'm going to write a general polynomial formula, and then we're going to see these guys, but this lecture focuses only on the x squared portion of it. So the polynomial formula that takes all orders in account will be p of x is equal to a0 plus a1x plus a2x squared plus a3x cubed plus dot 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 plus an minus 1 xn minus 1 plus an x to the n, and that's where it ends. So this is general polynomial formula. And you have all orders in this formula. Behold, this is a0. If you ignore the rest, this becomes y equals 3. Y equals 3 is a constant line, right? Constant function, line to 3. If you use a0 plus a1x and ignore the rest, then you have your mx plus b. That's linear lines, where a1 is the slope. And you have all of the straight lines which are slanted whichever way. If you use the first three terms, is what we are going to be concerned today with. And those three terms are quadratic formula. You know it as ax squared plus bx plus c. You've been factoring that thing forever in your previous courses, right? And probably solved some of the rudimentary equations with that. You have the third order, which has everything, and then you can go to the fifth, sixth, seventh, eighth, whatever the highest thing is that you need for the application. When you do regression in Excel, you will notice that polynomial regression goes up to 6, right? Order of 6. And you will use that for the project. We are focusing on quadratic polynomial, and that one is y of x or f of x equals ax squared plus bx plus c. This is one of the forms. We'll learn the other forms as well. So this is one of the forms in which you can find this one. And again, looking at the polynomial formula, that's this much of the general polynomial formula. That's what we are focusing on. And now I'm going to put the highest exponent first because that's the leading term, and then go in a descending order. So ax squared plus bx plus c. You know the graph for this already. You better know the graph for this. We start with y equal x squared, the most fundamental one you can have. Looks like this. It's a U-shaped graph. We call it parabola. And this point, which in this case is a minimum, is called the vertex. Note that a equals 1, which is bigger than 0. So we have positive value a, and that's the reason why it opens up. We call this orientation. So when you see this on the exam, don't waste everyone's question on it. What do you mean by orientation? Note that I said when you see this on the exam, not if you see this on the exam. I said when you see this on the exam. So pay attention to the words I'm using, sometimes incorrectly. When you compare the two functions over here, you can see that b is equal to 0, c is equal to 0, those do not exist. And then a is equal to 1. A equals to 1, 1 is bigger than 0, and orientation is up. What are other features that we need to know? Domain. What is the domain of this? Anyone? Domain? Negative infinity to positive infinity. X can be any value you can imagine, because any number you can come up with can be squared. Are we all agreeing on that? Perfect. What is the range for the graph you see? What are the y values that exist? Yes? Okay, 0 to infinity. What do I put? Parentheses, brackets, half and half. I don't mean half and half, you know. I'm sorry? Include 0. Very good. And obviously exclude infinity. Great. Vertex. What are the coordinates of the vertex on this one? 0, 0. That's a point. This is a good time to point out a very sad thing. Same notation, two different concepts. Negative infinity to infinity is open interval, and 0, 0 is a point, and they have same notation. I can have open interval 2, 3, and I can have a point 2, 3, and they have the same notation. That is unfortunate thing in the mathematics, and it happens with inverses as well. So you have to be very careful to get from the context, what are we talking about? Is it an interval or a point somewhere in space? Point is a location, right, on x, y coordinate system. So domain is negative infinity to infinity, and that is interval. Range is 0 to infinity, including a 0. That's also interval. Vertex is a point, and in this case, it's 0, 0. And in this case, vertex is also a minimum. So I'm just going to tag minimum here because it's a minimum. Further analysis of the graph would say that on the interval negative infinity to 0, function is decreasing. 0 to infinity, function is increasing. You know, things that you can see with your eyes. From negative infinity to 0, function decreases. From 0 to positive infinity, function increases. Important skill to have. It helps with looking at the graphs of stocks, for instance, you know, stock market. So, yep. And this is the analysis of x squared. X squared is what we call the default, right, graph. And then we can do the stuff from 1.6. We can move it left, right, up, down. We can scale it, shrink it, right, stretch it. We can do all of those things, and that is going to be preserved in one equation. All of those transformations are preserved in a single equation that we are going to call standard model, but I need to get there first. Before I jump to that one, the next one that I want you to do the same analysis for is f of x equals negative x squared. Draw the graph, get the domain, range, vertex, get the whole thing. Let's discuss this. So we start with the graph. The graph will look like this, because we know that from transformations, negative in front of function flips the function on x-axis. That was 1.6. This graph should not be foreign to you. Oh, you never told us that. Yeah, I did in 1.6. If you know the basic graph, and then you know the minus sign is the reflection on x, you're done. Domain. Anyone? Perfect. Range. Negative infinity including 0. Nice. Vertex. 0, 0, and it's what? Is it a min or a max when you look at a function? Max. Right? It's the highest point on the entire graph. So it's a max in this case. Great. Negative infinity is smaller than 0. Positive infinity is larger, right? When you line them up, you have negative infinity, 0, infinity. Right, so we're using this. Great. What else? Ooh, A. What's A equal to? Negative 1, which is less than 0. So opens down, and that's your orientation. I can't fit. It's orientation. I can't fit the word there. Actually, I can move everything. Orientation of the graph opens down. Does this function have an inverse? Just tell me yes or no. Is there an inverse? Yes. Is there an inverse function? Come on. No. Huh. Well, so wait, what is the difference between asking if there is an inverse and there is an inverse function? So, hello, 1.7, right? So, if your function is y equals x squared, the graph clearly does not pass horizontal line test. See that? It fails horizontal, fails halt. That means no inverse function. Do we have an inverse? Hell yes. The inverse is this. But you see, it fails vertical line test, so it's not a function. So this is an inverse. Not a function. So there is no inverse function, but you do have inverse. What is the equation for the inverse? Well, if you swap domain and range, you will get that f inverse of x is plus minus root x. There's a plus root x, the top branch, and minus root x, the bottom branch. So, y equal x squared is a function because it passes vertical line test. The inverse is not a function because it fails vertical line test. And you can also quickly determine that by using horizontal line test to see that the inverse is not going to be a function. Can we fix this? And the answer is yes. We use restricted domain of 0 to infinity on x squared. So how does it graph? Graphs this way. That's it. So we are taking half of the entire graph, and now this is still y equals x squared, but it's on the restricted domain 0 to infinity. When you do the inverse function on it because it passes horizontal line test, you just get this, which is y equal square root of x. So this part over here is the function, and this is inverse. And because we restricted domain, that inverse is inverse function. So restricting the domain helps. In some cases, it's the only way where you can have an inverse. I mean, inverse function. You always have an inverse. I just want to take one step, well, actually 7 steps back, and mention that if you have f of x equal 3x squared minus 5x plus 9, you can compute f of negative 2. I don't know if I mentioned that. I didn't mention this yet, but I just want to make sure that you know that you're just plugging a number in and grinding through this. So that's a 4, that's a 12, plus 10, plus 9, so that's 31. And this negative 2, 31 is a point that you can graph. You can compute others and you can connect them. But we are going to find a much better way of dealing with graphs than chasing the points. So these quadratic functions are functions, and you can compute the value. You can compute the difference quotient for it, right? You can do everything you did so far. So now I'm going to write here again y equals ax squared plus bx plus c, and then say when a is positive, the graph opens up. When a is negative, the graph opens down. $1 million question is, what happens when a is 0? What happens when a is 0? Think about it. Yeah, straight line. It's a straight line. Look. What happens here is this is certain value for a. Let's say a is equal to 2. And then a is equal to 1. And then a is equal to 1/2. You're supposed to know this from, that it's going to do this from 1.6. Then there's this one. A is equal to 1/4. You see that these numbers go 2, 1/2, quarter, right? You can come up with anything else. The trick is that you are moving towards this x-axis on which you get a equals 0 to be straight line. And then as soon as you pass and you get this one is a equals negative 1/4. Oh yeah, negative a, sure, that works. Negative 1/2. A equals negative 1. A equals negative 2. I don't know if you can mentally do the opening of this, right? But this, let me label y-axis. So from here, it opens out when a is 0 is flat. And doesn't that make sense to be flat? Look, when a is equal to 0, this term dies. What are you left with? What are you left with? Mx plus b, straight line. Exactly what you were supposed to stay with, right? So, can you have a quadratic function with a equals 0? Hell no. Because if a is equal to 0, it reduces to mx plus b immediately, right? So we are only considering a bigger than 0, a smaller than 0, because those are the ones that open the graph up, open the graph down. If a is 0, you killed the quadratic term. And it's no longer a quadratic function. It's linear now, right? You get a straight line. So a is not allowed to be 0 because it kills quadratic function. B and C can be zeros, can be anything. And a can be anything but 0. So I can actually note that next to the formula with the little a not allowed to be 0. Because it's going to kill the function, right? It's going to kill the function that we want to learn about. Now, let's learn this really cool form. And this really cool form is the standard form of the line. Start at y equals x squared. And then shift left, right. So the equation now changes into, I'll use h, right? Number 2, shift up, down. And we add plus k. Stretch. Or shrink. And that's your A. And I hope that you see that we actually built this just using concepts from 1.6. And instead of using, you know, what I used earlier, the plus minus C every time, now I'm using H and K. What you get is the equation. This is where the power is. Standard form. Why is this so cool? This is insanely cool form. Number 1, we see A. We see A in the other form as well. Number 2, we know coordinates of the vertex. Which is h comma k. And that is huge. I'm just going to actually go over here and put orientation. Again. So I'll go back to point number 1 and add word orientation. That's why we want to know this A. Now both forms give us A on a plate. But this particular form, the standard form, gives you vertex on the plate as well. And this is why it's so awesome. It takes 3 seconds to graph. Or 4 if you're slower. Y equals -3 x plus 2 squared minus 4. This is all I need to do, guys. It literally takes a split second. A equals -3 less than 0 opens down. Now, clearly, in many cases, you know what that means, so you don't have to write it down. And also, you have vertex at -2, -4. To graph this, -1, -2, 1, 2, 3, 4, open down. And then we say that this is a max. That might be a question. Do we have min or a max? You'll quickly figure out that all of these that are less than 0 that open down have to have a max. The ones that open up clearly have to have min. These are the things that you sort out when you are alone and thinking about these things. You see how superior this form is? It's really, really superior form for graphing. Not so much for other stuff. If you need to compute certain things, well, it might take shorter, might take longer. So we want to use the standard form. All right, here is the y of x is equal to 2 minus 5 squared minus 3. Do everything that I did before. Figure out A, figure out vertex, figure out opens up or down, and then draw the graph. It's a sketch. A is equal to 2, which is larger than 0. What does that mean? Opens up. What else do I know? Which is 5, -3. Nice. Well, that's what you do. That's when you compare the formula. So vertex open up. Is it min or max? Min. That's exactly what the next thing, just because of the 2 questions I got. All right, so note that the formula is y equals a x minus h squared plus k. Oh, thank you. You see? I was just testing you, and you did well. Very good, very good. Oh, you're writing in pen? Don't. And also get the square notebooks. I'm going to do it the right way. All right. What I'm going to do here is the comparison. Do we all agree that y is y? And equal is equal. Do we all see that a is 2? Is that bueno? Now, do you see that x is x and minus is minus? You see they match, right? So h must be 5. And over here what I see, some color coding, over here what I see is that k is equal to -3. Their sign is not the same. If the signs are the same, you get positive values. If the signs are opposite, you get negative values. It's always like that. Now, this is a crucial skill. A lot of unnecessary mistakes from not picking up minus and positive signs correctly.
So in both cases for h and k, if the signs are the same, you get a positive value.
Nope. For age is opposite.
For h is opposite.
If signs are the same, you get positive value.
So just k.
Well, let's see another example. So, how about I'll write the formula again: y equals a x minus h squared plus k, and y equals -4x plus 3 plus 9, whatever. What's hk? -3 and 9. Why is it -3 and 9? Yes. Now I want to show you how incredible textbook is. This is how incredible the textbook is. Look at this. Graphing quadratic functions with equations in standard form. They give you the equation. You know what standard form is because I just did it 15 times. Number one, determine whether the parabola opens upward or downward. If a is larger than 0, opens upward. If a is less than 0, you don't need me. You don't need me. I haven't even told you half of these things here yet, right? Look, this is impossible to make it clearer than this. Determine the vertex of the parabola. The vertex is h comma k. Go, go. Pick up the number. Find the x-intercept if you take the whole function and set it to 0. Solve for x. We'll do that now. Find the y-intercept by plugging in 0 for x. Plot all of these things you find and connect them with the smooth curve. So now we talk about intercepts. We covered the orientation, we covered the vertex, and now intercepts. Now, I'm going to call this life, okay? Because this is not just, oh yeah. I'm going to call this life because this is not just for quadratic. This is one of those properties that it's going to be used for every function you see under the sun. Every. And this is what it is. For y-intercept, set x equal to 0. For x-intercept, set y equal to 0. Why did I call this life? Because every function in the galaxy is going to use this. So our quadratic functions are not going to be exception to this at all. X-intercepts, which is where you set y equal to 0. So x-intercept cases. So default state, 1 x-intercept. We can have 2 x-intercepts. And we can have none. This glare is killing me. Can't even write. And it should be clear that there are no x-intercepts because it doesn't cross the x-axis. You create an x-intercept when your graph goes through x-axis or touches. We say also kisses the axis. So the first and the second have x-intercepts, and the last one does not because it doesn't touch or cross x-axis. Find the x and y intercepts for y equals, and this is where I go and steal a problem. Well, I have to make it up because so x squared plus 5x plus 6. So find the x and y intercepts for this. To find the x-intercept, we set y equal to 0. That means that we have x squared plus 5x plus 6 equal to 0. How do we solve this? How do we solve this with the what? Factor. Good. So we factor this, we get what? X plus 2. Okay. Anything else? X plus 3. Okay. Then we use the zero product rule to set each one of these to 0. And we have x is negative 2 and x is negative 3. So what are the two x-intercepts? Negative 2, 0 and negative 3, 0. Please note, guys, that these intercepts are points. Yeah, they're on axis because we said. And also make the connection. You are forcing y to be 0. You better have both y coordinates be 0. One more time. This calculation forces y equals 0. Therefore, your points at the end better have zeros on y locations. Y-intercept. set x equal to 0. Well, that's easy. 0 squared plus 5 times 0 plus 6, which is 6. So where's the y-intercept? It's at 0, 6. We have A, which says it opens up. And we can graph y equals 6. I have to go all the way up to 6. I have -2, -3, and they're very close to each other. 2, 3, 4, 5, 6. It goes through this. Now, we can exploit symmetry what I did is I used the same spacing from here to here. It's 2 units and 2 units. There's the 1 unit which is symmetric in the middle. So what I did is I used symmetry to find this point here because I want a better graph. There it is. I don't need the stuff in the middle. Observe that it goes below x-axis, right? So it's very easy to graph these guys when you have enough information. Orientation, vertex, intercepts, all of those things. And you know what? The more of these you compute, the better, because one verifies the other. Now, this was a not user-friendly form. It was ax squared plus bx plus c. What's your vertex? Now you see that the vertex better fall somewhere on -2.5, because it has to be exactly halfway between these two, right? And we don't know the y value. So you can kind of cheat using that idea. Or you can say that x coordinate of the vertex can be found as -b divided by 2a. How much is your b from the problem? How much is b? It's 5. And how much is a in the problem? 1. So what do I get for the vertex? Come on, just plug in. -5/2, right? Which is -2.5. It has to work out. Now the y coordinate of the vertex is going to be the function computed at the x of the vertex. So this is x squared plus 5x plus 6, but you have to plug in -5/2. Give me now. -5/2. Just compute that. You get a value. So square will kill the negative. You have 25 over 2. Minus 25 over 2. No, wait. Oh, it's over 4. That's why. So the first one is over 4. The second one is -25 over 2. And then we have plus 6. Common denominator here is 4. So I have 25 minus 50 plus 24. 25 and 24 is 45. Minus 50 is minus 5/4. Questions, concerns? Just questions. Concerns. I'm not qualified for concerns. Does this make any sense? Anyone? Thank you. Yes?
25 plus 24, right? 49.
What did I do?
You said 25 plus
25, 20. Oh, that's 49. This is negative. This is clearly negative quarter. It's obvious. Not bad with numbers. Good thing that my life doesn't depend on it. You want to go? Huh? It's going to be a lot of homework, and I will see you all in 5 days.